engineering side of things, in which I use a lot of Python, Pandas, Flask, right, and then Amazon AWS to build the data engineering project. So currently, I work for JP Morgan Chase. So been there for last 5 years. Total 16 years of IT experience, everything into Python. So I have had an opportunity to work with like monolithic architectures, and then microservices based architectures. So I have Python plus Django is something I have a lot of experience with. And recently I've been into more into data engineering side of things. So basically working a lot with pandas, uh, my MSSQL, then AWS, a little bit of Databricks. Um, so that kind of a role. Data engineering, data analytics, and the analytics part. Our reporting part. That is the backend is Flask. So yeah, there also I have I considerably do my work.
Okay, all right.
Yeah.
So you are more or less into AWS with Python, right?
Yes, yes, AWS with Python. Yes, that's correct.
Do you have any experience on API?
Yeah, yeah, I have experience on API. So I have experience on, like, if you say, I have been building APIs with Flask and Django REST API. Recently, yeah, I have started AWS with Lambda to deploy my APIs, basically Flask-based APIs, and we use API Gateway for transferring to the handler which is AWS Lambda, where we have our Flasks REST APIs written. So yeah, this is sort of thing that I worked
Okay, what is the difference between CloudFront and CloudFormation?
on. So cloud formation is mostly like cloud front and cloud formation. Okay, cloud formation is mostly like that infrastructure as code, wherein you can deploy your infrastructure using the cloud formation. um, Cloud front is mostly uh, cloud formation and cloud front. Yeah, cloud front is mostly like the monitoring bits that we do in AWS. I mean, the logging event and all that. Yeah. So,
Okay, so okay. Now move on to the next question. So my next question is to check. Okay, okay. Have you ever used Boto, and where is it used?
yeah, Boto is a Python library for interacting with the API. I mean, it is an API built over Amazon Web Services. So basically, you can automate some of the things. Even you can use it for infrastructure uh, creation in AWS. Yeah, I mean, you can interact with the services like uh, with Boto. You would be able to interact with the S3 buckets, your EC2 instances. So it provides a wide range of APIs to talk to your AWS services using Python.
Okay, could you please tell me AWS Lambda function? What's that?
Yeah, AWS Lambda function is a serverless, serverless compute platform built into AWS, which is a function, basically a function which accepts an event, and then based on the event, it does some sort of some sort of logic, and then it returns something. So these events could be like your S3. In your S3, if you have a new file uploaded in a bucket, so you could associate these kind of events to be listened from AWS Lambda. I have used AWS Lambda for deploying my Flask APIs, and connecting as an event. It connects to the API gateway, and from API gateway, this basically API gateway, you are able to configure your URLs, and the methods that you want to configure with, like get, post, put, delete, all these REST APIs, and then you can redirect it to the suitable Lambda functions for the processing, or to handle these requests. So yeah, I have used Lambda for that. I've even used Lambda for some workloads using serverless. So when we say serverless, then that means that we don't have to configure any like EC2 instances and all for our compute services, and we don't need to bother about auto scaling and all that. It is all built
Fine.
into AWS Lambda, and you can use it as it is.
Okay, so how AWS Elastic Load Balancing works? Can you explain?
Yeah, so elastic load balancers are basically a service in AWS which takes care of load balancing. Basically, if you have, you know, uh, a sort of a setup wherein you are, so basically to make your services highly available, services in the sense that it will host some sort of a web server, and to make it highly available, you can deploy your application into multiple servers by doing horizontals. You can basically have the copy of your servers in a multiple EC2 instances, and then elastic load balancers basically would make sure that it based on the load. So first, it is a load balancer. That means that it will redirect your traffic to a particular EC2 instance, yeah, based on number of requests that is there. But when it is called elastic, that means that if the load becomes much more, it would be responsible to actually do auto scaling, and then attach another EC2 instance, and then redirect the traffic to that EC2 instance. So yeah, so this is what elastic load balancers are.
Okay, could you please tell me something? What are the challenges you have faced in the cloud project, or maybe your recent project, and how did you resolve your team, or maybe what was your contribution? Can you explain that?
So basically, we had just moved out of our on-premise systems, which is on-premise data analytics systems, to cloud in AWS. And we have another greenfield project that is running, which is a cloud native project. Um, so the um, the on-premise cloud migration project that we have. In that, it was like a monolith, and there were a lot. It was all the services were written in one Git repository, and then we had to go to cloud basically. So this was a challenging thing for us because we had to understand that how do we do it, because there are a lot of dependencies involved. So we decided that we will go with containerized applications, uh, and use Amazon EKS for doing that. Um, so basically, we divided our monolith into microservices, and then used Docker to containerize each microservice, and then we use Kubernetes in order to make sure that we could run these Docker images in a Kubernetes environment inside EKS. And with that, we use the Kubernetes object load by horizontal autoscaler, so that we can even utilize our autoscaling capabilities when the load increases basically. So yeah, when the memory goes above certain threshold, it actually creates one more pod, and that way we have the auto scaling functionality built. So we had to do this way and not use something like AWS Lambda, because we had a lot of dependencies and we had a lot of legacy code, which had a lot of dependencies, and managing all that into Lambda was not a straightforward process. So this was a much more easier way for the developers to migrate all these services to some sort of microservice, and then we could Dockerize it, and we could use Kubernetes, and use EKS in order to deploy this service. So this was a 1.5 years project. So I came out with the solution to do this. So first I actually did a small amount of demo that we could actually go ahead and do that, and then had to talk to the stakeholders and all that. And when we got all the required approvals, then we went ahead to implement this with the team, and yeah, we were able to productionize it.